Electricity. Electricity is actually uh, a way of transferring something. There is a difference between electric energy and electricity. For example, think about a source of energy. So if we say a source of energy is some sort of oil, you burn the oil and you get some energy, that's a source of energy. Another way is carrying that energy. For example, you carry the oil through some sort of a pipe. So electricity is actually not a source of energy, but just a transfer of energy. This is very important that you remember. It's the transfer of energy. Now, in order to understand electricity, we have to start from the basic concept called charge. Now, if we think about matter, if we think about something, if you hold something in your hand, it has some property. For example, maybe it has, if you talk about a person, maybe how tall the person is, what is the weight of the person, what is the color of their hair, and so on. That's the properties of various aspects of the person. But when we talk about matter, matter has basically two types of properties. If we talk about matter, matter with which everything is made up of, matter has two types of property. One of the properties that matter is made up of something, and we call it mass. So, and the unit of mass, which is called the base unit, is kg. So when we say matter, we are talking about one property of matter is mass. Another property of matter is charge. Matter has a charge. It's a basic property of matter. Now, if we talk about charge, there are two types of charge. One is the positive charge, the other is the negative charge. Now you have to understand that this positive and negative thing, this is just a name. We could have called it black and white. We could have called it tall and short. We have to name something, so it was named positive charge and negative charge. That's all. For example, there is another concept called magnetism. We call that North Pole, South Pole. So here we had to name something. We use positive charge, negative charge. These are not actually mathematical names. So the first thing, we know that matter, everything in the world is matter, and if we hold a matter in our hand, maybe a piece of rock, it is matter. It has properties. One is mass. If you hold it, it is occupying space, it has mass, it is something you feel. And another property matter has is charge. Now later on, when we know about atoms, the positive charge is actually a particle called proton, and the negative charge is the property of a particle called electron. So charge is actually, we are talking about particles. Later on it was found out. Anyway, let's move on. Now, from the basic concept of charge, let us talk about the unit of charge. The unit, whenever we are talking about the unit of charge, suppose it could be positive charge, a unit of proton, or it could be negative charge, a unit of electron. When I'm talking about unit, I'm talking about a quantity. So the unit of charge is called the coulomb. Coulomb is the unit of charge. That means when I say 1 coulomb represents 6 million trillion, that's a lot by the way, 6 million trillion particles. That means it could be 6 million trillion protons or 6 million trillion electrons. So when I say 1 coulomb of charge, that's a lot of charge. 1 coulomb of charge is 6 million trillion charges put together. Suppose if you put If you say one box of chocolate, maybe it has 20 chocolates, so that's one packet. So when we say 1 coulomb, it's a packet of 6 million trillion charges. That's a lot. Now, one of the basic property of charge is that if it's same charge, like charges repel each other, like charges repel, and opposite charges attract each other. That means if you bring two electrons together, they would just bounce off each other, they would repel. If you bring one electron and one proton, they would just be attracted and come together. That's the basic idea. Now, every aspect of electricity could be explained with the concept of charge. For example, when we talk about current is nothing but the flow of charges. So current is the flow of charges. That's it. Speed of the charges. You think about lots and lots of charge going through you. So you stand and you time it. In 1 second, maybe 5 charges goes. You say the current is 5. Maybe 10 charges go in 1 second. You say the current is 10. So it's the flow of charges. Or we can call it the speed of charges. So current given by the symbol I, charge is given by the symbol Q. It is Q divided by time. So the speed of charges is Q divided by time, that is current. So the unit of current is ampere. So when we say 1 ampere, it is 1 coulomb of charge that passes per second. In 1 second, if 1 coulomb of charge passes, that means if 6 million trillion particles, it could be positive charge particles like proton, it could be negative charge particles like electron, if in 1 second 1 coulomb of charge passes you, that's 1 ampere of current. That's the idea of current. So when we talk about current given by the symbol I and the unit is ampere, is Q by T. That's the idea. After current, the next concept that comes, that's called voltage. So voltage, or this is also called potential difference, and another name is also for a battery is EMF or electromotive force. When we say voltage, voltage is actually the energy. Voltage is the energy that a coulomb of charge has. So whenever we are talking about voltage, we are talking about the energy. Now think about this as a bowling ball. For example, this is 1 coulomb of charge. Now maybe this is a bigger bowling ball, so it has a higher energy, and this is a bigger bowling ball, it has a higher energy. So every time you're thinking about a coulomb, think about a black bowling ball, and when I say voltage, it's the amount of energy that this coulomb has. Now think about the basic quantity of energy. Energy is actually a thing. Whenever we are talking about energy, we are actually talking about a thing. So if I say energy, energy is a thing, a very very real thing. Just like matter, just like the universe is made up of matter, universe is also made up of energy. As a matter of fact, matter and energy, they're the same thing. It can be converted to one form to another form. Matter can be converted to energy, energy can be converted to matter. So when we say energy, it's a real thing, but it is very difficult to define energy. So we use energy, the definition as the work done, meaning energy is the ability to apply force over a distance. So since if someone tells you what is the definition of energy, you have to understand energy is a thing. The universe is made up of things, matter and energy. So energy is made up of, universe is made up of matter and energy. But to understand it, we give the definition of energy as work done, the ability to apply force over a distance. Remember, if someone tells you where does force come from, force comes from energy. That's where force comes from. If someone asks you what causes something to move, well, force does not cause anything to move. Energy causes something to move with the help of force. Force causes changes in motion. So energy is the ability to apply force. Every force in the world comes from energy. So that's the definition of work done. So think about voltage as energy per coulomb. So if you think about energy is distance, force times distance. So if someone takes a ball and puts it here, so if it falls over this distance, it is going to have some energy, especially if it falls over your head. Now this will have a higher energy because it is falling from a higher distance. So what happens, the further away it is and it could fall on your head, it could cause more damage because it has more energy. So because one of the definition of energy is, because we cannot just say energy is a thing, energy is a thing. So understand, we say energy is the ability to apply force over a distance. So this is a longer distance, this is a longer distance than this. So this will have higher energy. So think about voltage, something like that. Think about these bowling balls. So if we say something has a voltage, suppose 1 volt, we say that it has 1 joules of energy per coulomb. So we are talking about a joule of energy for 1 coulomb. If it has 2 volts, it has 2 joules of energy for 1 coulomb. If it's 3 volts, 3 joules of energy per 1 coulomb. It's always 1 coulomb, but so energy, you can think about this distance that it is following. So the higher the voltage, this could fall more. So this could fall more, and because of this voltage it falls, meaning because of this distance it can fall. If something is on the floor, it cannot fall, it cannot travel. So because it is because of the energy that it can travel. So whenever we are talking about voltage, we are thinking about energy. So we can actually say that this is measured in volts. So when we say 1 volt, this is 1, that is unit of energy is joules. 1 joules of energy per coulomb, meaning C-O-U-L-O-M-B, coulomb, meaning the amount of energy that 1 coulomb of charge has. It's all about energy because the universe is made up of matter and energy. So the voltage concept is very, very important. And the formula for volt is going to be, let me write it out here. Formula for volt is E, energy, divided by Q, coulomb. So V equals to E by Q, energy by coulomb. So let me do one thing, let me write this formula again. So what we have so far is, we have current equals to speed of charge, Q by T. We have voltage equals to energy by coulomb, E by Q. Unit of charge is Q, and the symbol for charge is Q, and the unit is coulomb. So this is the first two formula that we have. Now since we are talking about energy, we have to talk about a concept called power. Now power means the download speed of energy. So everything in the world is about energy. When you pay your electric bill, you're paying for energy. When we're talking about the light, we're talking about the energy that we're getting. It's all about energy. So it's not good enough to know that you need energy. You need to know how fast can you get the energy. If someone tells you that you need 10 gigabyte of space, so it's all about, in the internet, it's all about how much can you download, how much can you do that. But it's not just about the amount of things that you can download. It is also about your download speed. How fast can you download it? So the download speed of energy, that's called power. So when we talk about the download speed of energy, we are talking about power. How fast can we get the energy? So rate of energy, which is given by the formula P equals to energy per time. Rate of energy, the speed of the energy. So this is the formula for power. So power equals to energy by time. That's the formula for power. Now one important thing is that using algebra we can actually rearrange this and also find a new formula. Power equals to IV. This is actually very simple, because we know that volt is energy by Q. So instead of E, I can write VQ, and I know Q by T is I, current. So I can rearrange this algebra and get a new formula. So that's it. That this is nothing fancy, just basic algebra. So the first important concept of electricity is charge, the most important thing, and from the charge we get current, we get voltage, and we have to understand the concept of energy as well, and from that energy we have the concept of power. Power is the download speed of energy, how fast you are getting the energy. So this is electricity in a nutshell.